Hi everyone, welcome back to PyVista. Today we are going to try different approaches to measure the collision between two 3D objects. For that, we are going to use PyVista and Open3D, also sign distance field. So one can say to measure the collision, I just need to extract the area of collision and then taking the bounding box of this area, this will be our area of collision. But in fact, it's not real things. To do that, we will have a ground truth. What will be the ground truth? It will be in fact 30% of 0.5, which means 0.15. So this will be our ground truth. How? We need to create first two spheres with radius 0 and radius 1 about 0.5 and 0.5. Then the penetration ratio, we are going to translate one to the other sphere by 0.30, meaning 30%. And when we need to compute the ground truth, which is the area of penetration, it's only 30% times this thing, which is the radius of the sphere. So this will be in fact penetration ground truth, which will be here, as you can see, 0.15. Then the center distance just for computation. So let's go ahead in the code. So now we just compute the sphere using PyVista. As you can see, I'm using the radius, the first radius and the second one. Then the collision data, so I'm extracting the collision using the built-in function from PyVista, the collision regions, and then I compute the bounding box using VTK bounding box. And we will see the visualization of that in a few minutes. So now let's continue. Now I'm using Open3D to create exact same thing, but then to use sign distance field. Just let's take a moment about that. Why sign distance field can be the great approach to get in fact the penetration, the real penetration ratio. Because in fact, if I'm taking only the area of the bounding box, it's not real. It's not true. I computed the triangle mesh create sphere from Open3D, both of them. Then I translate one to the other by the center distance. I get exact same things like PyVista, and then I continue. Now I'm working on the SDF, on the sign distance field. Let's come back to the previous function. If you need more explanation about sign distance field, you can go to my previous video on generate an envelope mesh using sign distance field SDF, and all the explanations are over there. Let's see. So this function is taking in fact the first mesh and then query points. When query points, it's like part of a volume. So we just need to imagine we put a mesh in a volume. This volume can be infinite, and all the points of all the voxels of this volume will have a certain distance to the surface. If it will be inside the surface, so the distance will be negative. If it will be outside of the surface, the distance will be positive. So if we have the query points, which are, for example, our penetration, our collided object inside our main object, so then it's meaning the distance from the query points to the surface of the mesh will be negative. And then we can take this absolute value of this negative and we will have in fact the penetration ratio. So let's go ahead. So we need to first get the triangle mesh of our sphere, which at the beginning it was in point cloud. Then we compute the recasting sen, a triangle on the sen, and then the query points and the compute sign distance. So it's a built-in function from Open3D, as we already saw in the previous video. Then we just return sign distance. Let's see, in fact, here the sign distance is it's a SDF on moving. So let's see here SDF on moving, and we can see that we have 50,000 points, and all the points are in fact only distance, and we can see here the minimum and the maximum. We see that the minimum is about minus 0.15 in fact, and it's very close to the 0.15 at the beginning, our ground truth. And the maximum distance is this values, which is basically less important for us. So let's continue that by just running that at the end and see the visualization. Yeah. Okay, we will analyze the table just later. So here, okay, we have two spheres. We have penetration of this sphere in this one by 30%, because we know that this radius is about 0.5, so 30% of 0.5 is about 15, okay, 0.15. So we know that the ground truth of this penetration between this point of this and this point is about 0.15. But when we take, someone can say, okay, I just want to take the area of collision, which is the area in yellow, and then take the bounding box using PyVista or Open3D, and then take this thickness. In fact, the thickness of the bounding box will be our collision value. But in fact, if we compare that in this table, we can see that the thickness of the bounding box of Open3D is about 0.07, of PyVista is about 0.07, so it's pretty close. But we can see that our ground truth is about 0.15, so meaning that this approach is not the good approach. If we want to know the exact collision, we are obliged to use sign distance field. If we so this is a good value, so it's completely correct. And now if we want to know the direction of the collision, we can use the gradient of the sign distance field. This gradient will allow us to get the direction of the collision and then go to correct in fact this direction. So what is the message of this video? And I close this video with this. Is when we want to use, in fact, the collision, when we want to compute the collision between two 3D objects, we need to use sign distance. That's it for this video. Thank you for listening to me. Please share this video and let's go ahead with the next video next week on a great topic. See you soon.